Welcome to the 21st lecture in the course of Industrial Engineering and Operations Research. Today, I will explain about line balancing. Let us understand this topic in a very simple way. Assume that there is one factory which makes some special machine which takes 8 hours to produce. If somebody works on the machine, if one man makes one machine, it may take 8 hours. So, what happens that if you take a machine, now total you have got in a day, you have got 8 hours, and 8 hours you started the job and then it will make 8 hours. Now, what happens that if there is a demand that instead of one machine in a day, 8 machines should be made, then how we can do, because one machine takes 8 hours to make. Naturally, that it is a way out is that parallelly lot of work should be done. That means we need a machine every 1 hour to be produced. So, it is better that I can make some workstation, I can arrange say workstations in line 1, 2, 3, 4, 5, 6, 7, 8 and assume that there are 8 workers and each one does work in a sequence and each station takes 1 hour. 1 hour. Then it will become a continuous line type of thing and the production line may run. What happens that one machine is being coming out and after that another machine is behind this one. So, we can have, let us say that we have 8 machines, okay, that machines I am indicating by circle and they are moving through the station. There may be automatic conveyor system, each machine is taking 1 hour in a station. So, this machine has come out and after that another machine is coming, after that another machine is coming. So, this work will be done in a sequence. So, now what we have to do, this is called a production line, particularly used in mass production, automobile shops etc., that where you are bringing out car every minute or maybe every second also. So, production is very high and it is just like a flow type of thing, but you have many workstations and they have to be balanced. It should not happen that in between one station, suppose it takes 5 hours, then the work will be held up. But if it is balanced, it is okay that and not only that, balancing means this also, that suppose you have made a station of 1 hour, so it should not be that in that station only half an hour's job is there, then in half an hour the workstation will be idle. So, all these type of aspects we will discuss. So, line balancing in production system means line balancing is the process of assigning tasks to workstations in a production line so that the total time required at each workstation is approximately the same. It is a method of distributing workload evenly across workstations to optimize production flow, minimize idle time and improve efficiency. It aims to synchronize operator and machine time to match the required production time. So, now basically in a simple way, what is a line balancing? It is process of assigning tasks to workstations. That means we have made workstation. So, first you have to understand, if we want to do the make workstations, then the task required to make that machine should be breakable into number of activities. If you cannot break, suppose there is only one thing, that if suppose a painter is making a painting of creative art thing, then naturally he cannot make the line balancing type of thing, because we cannot break that when he is making that head, meantime other person is making the lower part of the body, that is not possible in the painting etc. So, therefore, there it cannot be done, but if you can identify that these are the tasks and they can do in parallel or they can do in some sequence also, then it is possible. So, this point has to be understood. And what are the goals of line balancing? Equalize workload. That means, if we make 5 stations, in each station the work should be same. Minimize idle time, then maximize efficiency, then reduce cost, improve productivity and efficiency. Productivity means something you can say ratio of output to input. Okay. Identify and eliminate bottlenecks, which tasks are taking more time, and determine production speed and manpower needed. So, all these type of things mathematically we understand. So, line balancing improves productivity. Now, productivity refers to the efficiency with which resources are used to produce goods or services. We can say productivity, usually we can define productivity as output by input. So, suppose one company is giving output of 2 and it takes input as 1, then you can say productivity is 2. But suppose another company is giving more output, but it takes more input also, then its productivity will be less, although the production will be more. So, productivity and production are two different things. Productivity is indicates that how efficiently you are utilizing resources. Then line balancing reduces cycle time and bottlenecks. What is cycle time? It is the time it takes one workstation in process to complete its workload for processing a part. Now, why it is done told cycle time? Because we are making many products repetitive way, one after we are producing car. So, one car is coming, another car is coming, another car is coming, and that particular workstation is doing one job, maybe fixing a wheel to the car. So, one is done, after that another will come. It is like a cycle that started fixing the bolt and then finished the final that one. So, you just it is one cycle is complete, then another thing will also start there. Or in a painting station, painting started, painting finished. Another for next product, painting started, painting finished. So, it is just going on a cyclic way. That is why it is called cycle time. Cycle time is the total elapsed time to move a unit of work from the beginning to the end of a physical process. And line balancing also optimizes manpower and resource utilization. Why? To make unnecessary workstations. If you can do many tasks in one workstation and with one worker, so there is this one. Now, let us understand the example of unbalanced lines. So, I am making a very simple picture. Suppose you divide task in two things, okay, two categories. That means some tasks are done on station 1, and then after station 1's job is completed, then product moves to station 2. Let us say in station 1 it takes 10 minutes, but in station 2 it takes 1 minute only. Then you see that station 1 will be overworked, it needs 10 minutes, and station 2 will remain idle, because station 2 that job is finished in 1 minute, then it is waiting for another 9 minutes to job to come, and then it will start. Say for example, in car assembly, if there is a delay at paint station, naturally that affects the entire production. So, assembly lines can be single model assembly line, or they can be mixed model assembly lines. A single model assembly line is a production system where a line is dedicated to assembling only one type of product. This contrasts with mixed model lines, which assembles multiple product types. Single model lines are typically used for high volume production of a homogeneous product, and mixed model can be mixed also. And these line balancing are common in manufacturing, packaging. I am just putting some picture. It shows the assembly line for a car manufacturing. So, this is a line, cars are moving, they are in line, and in each station job is done, station to station. They may move on these rails, and stations are set here, this is another station, like that. So, how do we define some terminology? Workstation, a specific area or location within a production line where a particular task or set of tasks is performed. Example, station for painting. Task time refers to the time required to complete a specific operation or a task at a workstation, that how much task is to be done, okay, in that workstation. And cycle time refers to the total time it takes for product to move through a specific stage or workstation in a production line. So it may include productive as well as non-productive time. How much time, even if it is waiting at that station, that time is also counted in cycle time. It essentially measures the time it takes for each unit of work to move from the beginning to the end of a particular process. Task time may be only 2 minutes, but the cycle time is 3 minutes. That means maybe 1 minute, it may be just waiting. Precedence constraints. Precedent constraints refer to the required sequence of tasks or work elements that must be followed when assigning tasks to workstations. So there is some precedence, this should be done first, then after that it should be done next task. These constraints ensure that certain tasks cannot be completed before others, impacting the order of operation along the production line. And then there is a term called line efficiency and balance delay. What is line efficiency? Line efficiency is a metric used to assess the effectiveness of line balancing. If your line efficiency is 100%, nothing like it. Measuring how well the line is operating compared to its theoretical capacity. Balance delay, it refers to the percentage of a time a production line is idle due to uneven workload distribution among workstations or operators. It is a measure of how much wasted time exists on the line because some stations might be idle while others are overloaded. So that is balance delay. Now what assumptions we make in simple line balancing model? Tasks are predetermined and fixed. Then task times are deterministic and known. No worker learning or fatigue considered. Precedence relation is known. Each task is considered indivisible and is to be performed at a single workstation. So particular task cannot be broken into two parts, that you cannot say half task is done here, half task is this one. You have to divide. Maybe entire machine making may contain 50 tasks, but those 50 tasks, each one of is indivisible. Now no work in progress, that means work in progress buffer is not there. There is no buffering or storage between workstations and no parallel stations. All workstations are arranged in series and no parallel processing is required. Now, so you know that cycle time is the actual time it takes to produce one unit from start to finish, including all value added and non-value added activity. This is cycle time for the whole one. Similarly, we can have cycle time at each workstation. Take time is a terminology that you know it is defined as available time divided by customer demand. So that means time which is allowed to you for making one product, that is called take time. Okay. If I have say 8 hours shift, but customer demand is 8 machines per day they need, so my take time comes out to be only 1 hour. So take time will guide you that one, and yeah, so cycle time has to be smaller than take time. Line efficiency and balance delay. Efficiency is equal to total task time. You sum the task time divided by number of stations into cycle time. Suppose a work contains 10 activities. Sum of activity durations is suppose 120 minutes. Let us assume that the cycle time is 30 minutes and there are 5 stations. So then the line efficiency will be 120 divided by 30 into 5. That means this becomes 0.8. So percentage efficiency comes out to be 80%. So this is and balance delay will be 1 minus efficiency. In the given example, balance delay is 1 minus 0.8 is equal to 0.2. We can also define smoothness index. it measures distribution of load, and lower index you get better the variance. So, smoothness index is indicated by SI, it basically a type of standard deviation. So, you say sigma I is equal to 1 to k, k is the number of workstation, T maximum station time and minus Ti is the station time of the individual one. So, you whole square and sum that. So, naturally if the time in each station is equal, in that case this will come out to be 0. Okay. Now, steps in line balancing. How do we do line balancing? First you have to list tasks and times, then identify precedence relationships, then draw precedence diagram, then select cycle time what you need, then assign tasks to workstations. Now, graphical representation of task dependencies is shown here. It helps in identifying task sequence, that suppose A can be done, but after A you have to do B, and you cannot do C unless B is complete, but D, C, D, E can be done in parallel way. Then F and G, if C is complete you can do F, if D is complete, D and E both are complete, then only you can do G, and if F and G both are complete, then only you can do H, but I can be done after completing H, and J can be done, then K can be done if I and J are complete, and then after that L and M. Like that we have made that. And there are many rules which I am just reading, but I will explain this thing in a very simple way at the end of this video. But I am just telling that if you want to go in depth, of course you can read from specialized books on this topic, many type of methods. So, one is the largest candidate rule. This rule prioritizes tasks with the longest durations when assigning them to workstations. Kilbridge and Wester method assigns tasks based on their position in the precedence diagram, grouping them into columns that reflect the sequence of operation. Tasks in earlier column, that is those with fewer or no predecessors, are assigned to workstations first, moving progressively to later columns while respecting precedence and cycle time constraints. And then ranked positional weight. This method considers both the task's duration and the duration of all subsequent tasks when determining its priority for assignment. Each task is given a positional weight that reflects its importance in the overall production flow. Tasks with a higher positional weight are prioritized for assignment. A task that has a long duration and is followed by many other tasks will likely have a higher positional weight and be prioritized for assignment. Now, I am giving that one simple example of deciding the number of workstations. So, number of stations required for designing a new station is estimated by take time. Say mobile phone company has the target to produce 400 units per day within an 6-hour shift. So, the take time is calculated as available working time divided by customer demand. Now, the shift is only of 6 hours. So, 6 hours into 60 means these many minutes you have got, 360 minutes you have got, but you have to produce 400 units because this is the demand from the market. So, it comes out 360 by 400, that means 0.9 minute. 0.9 minute means 54 second. So, take time is 54 second. That means 1 unit should not take more than 54 second. So, each station should have at most some 54 second time to meet the demand of 400 units. Each station, I cannot have any station that takes 60 second, because in that case I will not be able to produce. Okay, I can have one station which takes only 50 seconds, then 4 seconds it will be idle, that is okay. Now, say the mobile company has to undergo 13 steps to complete the assembly of mobile phone. So, there are 13 different tasks needed, A, B, C, and corresponding time taken in second is also given 12, 25, this one. So, if we go by that, it takes 27 seconds. If we pick up one mobile and start doing these tasks one by one by one person, naturally that he will take save 270 seconds to do that. So we have to make that in workstations. This job has to be done in such a way so that I can produce take time of 54 seconds. So number of stations is calculated by minimum number of stations is total task time divided by take time. So task time is 270 divided by 54 is equal to 5. So that means you have to make 5 stations. So in each station, of course, if it takes 54 seconds, then total time will be 54 into 5, 270, and my job will be done. So 13 tasks are to be completed within 5 stations. Some tasks have to be completed prior to other tasks. It has to be decided which task to include within a specific station. The order of carrying out the tasks are detailed by precedence diagram. Precedence diagram is a process flow diagram with arrows describing the steps within the assembly of the product or service. So this is the precedence diagram of these 13 tasks. It is to be inferred from precedence diagram that task B can be started only after the completion of task A. So task B can be only this one, and task C, D and E can be started simultaneously after task B. Task F and G have to be completed before starting task H. Then tasks I and J can be started simultaneously. After that, tasks K, L and M are to be completed one after the other. So next step involves assigning tasks to stations, and approach is to use task assignment table. I am just making that. So first, this is a table. You see task, time and immediate predecessor. Immediate predecessor. So this is immediately preceding activity. Before task B is A, then before C, B, like that we have done. Before I is done, then my H should be complete. Before K is done, I and J both should be complete, like that. So now let us assign the tasks. So we have got only cycle time of 54 available to us, and we are making the stations. Let us say minimum 5 stations we have to make. So let me make one station, and here we see that what are the eligible tasks. So eligible task first is only A, because you cannot do B before doing A. So therefore we have got eligible task A, so therefore assign it, and it takes 12 seconds. So cumulative time is 12, remaining time is 54 minus 12 is equal to 42. Then you can do B, you go on assigning, assign task is B, then task time is equal to 25 of B, then 12 is already taken. So 12 plus 25 means 37 got consumed, and we had 54 seconds here. So 54 minus 37, 17 seconds is still left in this station. Then I can assign C, and I can assign C, and I can also assign E. I cannot assign D here. D is also, but because D takes 40 seconds, but I have only 17 seconds left. So therefore I can assign either C or E. So that's why I say both are eligible, but then I am assigning C. Why? Because C is taking the largest time, 15. So that's why 37 plus 15, 52, and 54 minus 52 is 2. So 2 seconds is still remaining, but is there any task that takes 2 second time? No task is there, and it is not possible by precedence thing also. So we have to leave it. So this station got some delay, that means 2 seconds is remaining time. Okay, leave that. Make another station. Go to station number 2. Okay, and in station number 2, what you have to do that? In station number 2, you make that eligible task is D and E. After C done, D and E both can be done, but I am assigning D. Why? Because D takes maximum time, 40. So first give the bigger thing, 40, 40. So 50, so 14 second time is left. Then you see eligible task is E, and this is E, and then what happens that here E takes 13 time. So 40 plus 13, 53, and now there is no task which can be done in 1 second. So leave it as it is. there is a delay of 1 second. 1 second this workstation will be idle, and therefore 54 minus 53 is equal to 1, and it is done. Now go to station number 3. Here this is F and G, both can be assigned here after E, F and G. F, because F can be done after C has been done, and G can be done if D and E are complete. Naturally H cannot be done because F has not been able to do H. So therefore these two tasks are eligible, but out of that F takes maximum time, so it is 40, and so therefore 54 cycle time was allotted. So you still have 14 seconds left. Then you can see that G can be done in 7 seconds. So 40 plus 7, 47. So 54 minus 47, 7 minutes. This workstation will be idle, 7 seconds rather, but there is no task which can be done in 7 seconds. Of course M can be done in 7 seconds, but because of the precedence thing, we cannot take M. We cannot bypass M. Already first you have to do other task. So we have to say that I have to do that. Fourth, now eligible task is H, and it is you have to do H, and then it takes 15. So 54 minus 15 means 39 minutes. Then I and J both are eligible, because after H I can do either I or J, but I takes 37 seconds, J takes 28 seconds. So maximum time is taken by this one, 37. So therefore you better assign J, this is a 37 second. So it is a 37, and you say 15 plus 37, 52, and this is 2. Then you go to the fifth station. Now J is the eligible task, but it takes 28 seconds to do. So you are having remaining time 26. Then after J you can only do K. So this is K, J, after that K, and K is equal to 22. Second time it takes, so 50. So 4 balance delay you are having. Now you have to make sixth station for L and M. So L is equal to 9, and it takes, but you are having 45 seconds left. Then M 7. So this is the thing. So there is you are getting huge delay of, say means rather idle time of 38 seconds is still there, but you can't do right now. So there you can have probably more efficient approaches to do that, but this workstation naturally requires, this scheme requires 6 workstations here. Okay. So this is not 100% efficient. So in the rank positional weight method, we calculate positional weights, and we take task time plus successor's time, and we rank and assign tasks accordingly. So here you have say simple example, A no immediate predecessor and task time is 5, B has got predecessor and this is a 3, and C has got predecessor, that is A, and this is D has got this one. So positional weight of a task is its own task time plus R successor's task time. So 5 plus 3B plus 2C plus 4D. Task A has got 14 because ahead of it there are B, C, D. Task B has got only D ahead, okay, because A, and after that only D ahead because that another can be done parallelly. So this is 7. Task C also has got D ahead. So 2 plus 4D is equal to 6, and task D has no successor. So its positional weight is 4, and therefore task A will have high priority by rank task by descending positional weight. So task A, task B, task D, and that way you can do that, and then assign to workstations if cycle time is given. Like that you can do. Sometimes we make parallel workstations when task time is more than the cycle time, then we have to make parallel this thing. It improves throughput but increases cost. Mixed model assembly lines, different product variants on same line, it requires flexible scheduling and task planning. Two-sided line balancing used in car assembly lines, tasks assigned to both sides of conveyor. Then stochastic line balancing considers task time variability, huge probability here. So that is also there, but I am not telling. And line balancing in industry, these are some examples. Automobile, electronics, appliance sector, one by one they keep doing. Case Toyota, Dell, these companies are making use of that. There are some software tools for line balancing, Arena, Siemens, Technomatics, Witness, and they help in line balancing, and you can run the simulation. Common mistakes in line balancing: ignoring precedence constraints, then overloading a station, that means it takes more than the cycle time, and wrong cycle time selection. Okay. So basically we told that line balancing improves efficiency, use appropriate heuristics or software, evaluate line performance matrices, and there are a lot of material is also available in the internet. One is reference I am giving. This is made by some company. So this material also you can see, and that's all for today. Okay, thank you.